Good morning, statistics students. If you hear my teeth chattering or you see me shivering, that's because it's 60 degrees inside the classroom this morning. It's a little bit cold. So in this video, I want to go back in time to when we were doing discrete distributions. And we're going to learn to play Yahtzee because there's a lot of probability involved in the strategy of which dice you hold in playing Yahtzee. So here's how the scoreboard works. And if you play the actual board game Yahtzee or table game Yahtzee, there's no board. The score sheets are written in two halves. On the left side, you have all these numbers. So in aces, you roll the dice and you keep all of your ones. So if you end up with 3 ones, you get a score of 3 here. And then in twos, you keep your 2s. So if you end up with 3 2s, you get a score of 6 here, and etc. 3s, 4s, 5s, and 6s. If you end up with 3 apiece, so 18, 15, 12, 9, 6, and 3, that will add up to a subtotal of 63 points. If you get 63 points or more, you get a bonus of 35 points. Now on the right side, 3 of a kind. You get, as long as you get at least three of one number, 3 4s, then as long as you have 3 of one number, you add up the value of all the dice and put it here. Over here, you would only add up the value of the 4s. Here, you would add up your 3 4s plus the other 2 dice. 4 of a kind, as long as you get 4 of one number, you add up all the dice. A full house is 2 of one number, 3 of another. And that's worth 25 points straight. A small straight is 4 in a row. So you can get 1 through 4, 2 through 5, 3 through 6, and that's 30 points. A large straight is 5 in a row. So you can only get 1 through 5 or 2 through 6. And that's 40 points. A Yahtzee is 5 of a kind, and that's 50 points. And if you get more than one Yahtzee, each additional Yahtzee is another 100 points. So that's pretty nice. And then chance, you got nothing. You just add up all the value of your dice. You can see you can only put 1 score in each category. The game's over when you've put something in each category, even if it's a 0. So that's scoring. Let's just play the game for a moment. So you have 5 dice, and I have 2, 3, 3, 4, 6. Well, the easiest thing that I'm going to get here is some more 3s. So I'm going to hold those 2 3s. You get 3 rolls per attempt. And I didn't get them. Now I could take 6 for my 3s. Any of these others, I could take 0s. I could take 6 here, 12 here, 5 here, or just add them up and get 23. To be perfectly honest, 23 isn't a bad chance score, so I'm just going to take that. Two, 4, 4, 5, 6. Say, man, just held 2, 4, 5, and 6 and hope for a 3, for that large straight. Oh yeah, but the likelihood of getting a 3, there's a 1 out of 6 chance that I'm going to get a 3. And then there's a 5 6 times 1/6 chance that I wouldn't get it on the first time, but I'd get it on the second time. Not a good probability. I'm going to hold the 4s. All right, so I've got my 3 4s, and again, as long as you have 3 of each number, it'll add up to 63, and you get the bonus. You always want to shoot for that bonus. Now, I could take the full house here, but I'm not going to. I'm going to shoot for more 5s. Full houses come fairly often. I'm going to shoot for more, shoot for more 3s. Okay, Not bad. 2, 3, 4, 5, 6. That's a large straight right there. Boom. 5, 10, 15. I'm liking this. 3, 3, 4, 5, 5. I'm going to go 3, 4, 5. For a large straight, I could get either a 2 or a 6. And I get a 2. 1, 2, 4, 5, 6. Well, that's crap. I'm going to hold the ones. Nope. Get some 2s here. Aha. Do I take the 2s or the full house? Now, I could take 6 points on 2s, or I could take 25 on full house. I think I'm going to take that. I'm going to hold the 2 6s. Hope for another 6 or more. And it doesn't happen. So if I hold these 2 6s, I'm going to be down a few points. Instead, I'm just going to take that 1. Because remember, I'm 3 points up here. And when I say up, I mean towards that bonus. I need an average of 3 of each of these. Well, I'm up 3 points here. I'm down 2 points here. So if I get 3 here and 3 here, I'm still going to get the bonus. 1, 2, 3, 4, 4. I'm going to hold the 4s and hope for 3 of a kind. Aha, 4 of a kind. Doesn't happen often. All righty. So I need 63 points. I need 5 points. So I still need all 3 2s in order to get the bonus. 2, 4, 4, 5, 6. I'm going to hold the 4s, hope for 3 of a kind. Now I'm going to hold the 2s, and it didn't happen. I'm going to take a 0 here for Yahtzee. Now this down here on this electronic game, I can give like 3 bonus rolls. I'm not going to do that. I'm going to play as if I were playing for real. So I'm going to take a 0 here on Yahtzee. Going for 3 of a kind. All right, now in this game, it's not the way it's played in real Yahtzee, but since you're playing not against somebody, just the computer, if you get 220 points, you win. So all I need is 1 2 for that. All right, I've just won the game, but I would like to get that bonus down here. And I'm going to get it. There you saw I got that 35-point bonus before it disappeared. I ended up with 260 points, only needed 220 to win. Yay me. So that's Yahtzee. I'm going to pause this for a minute and turn the lights back on in here, and then we'll talk about some probabilities. All righty. So let's take an example. Let's say this was my first roll. 1, 1, 3, 3, 5. What would you do? What would you hold here? Assuming you don't have a full house, I would hold these 4. So I now have, I'm rolling only this die because I've set these aside. I'm rolling only this die. What is my probability of getting a full house? Well, what's my probability of getting a full house here on the second roll? I've already got a 1, 1 or a 3, 3. So I need either a 1 or a 3. So my probability is 2 out of 6 that I get it here, or 1/3. What if I don't get it here? Well, there's a 1/3 chance that I get it here and a 100% chance that I'm going to roll. So this is really 1 times 1/3. If I get it here, I'm done. If I don't get it here, what's the probability that I don't get it here? 2/3. And what's the probability that I'll get it here? Well, there's a 2/3 chance that I even get here, and there's still a 1/3 chance that I get the full house. So in 3 rolls, it's 3/9. 1/3 is 3/9 plus 2/9 is 5/9. There is a 5/9 chance that if I get these on my first roll, then I'm going to end up with a full house. So better than a 50% probability. Now, some people want to go 1/3 plus 1/3 and keep going. Does that mean that if I get 3 rolls, that would be 1/3 plus 1/3 plus 1/3 would be 100% chance? Does that mean after 3 rolls, I'm guaranteed to get a full house? Obviously not. It's 1/3 chance here, 2/3 chance here. There's another 2/3 out here. Let's see, make sure I'm doing that right. Yep, another 2/3 out here times 1. That'd be a 4/9 chance of getting out here times 1/3. It just keeps going on and on. If you think about it, it would be an infinite geometric sum with an R value of 2/3, and that is going to add up to 1. But just keep going. 1 to 2/3 times 4/9, yeah, et cetera, et cetera. So anyway, we have to stop after the 3rd roll, so there's only a 5/9 chance of getting a full house. Well, only, it's pretty good. Let's try another problem. Alrighty, on this one, 2, 3, 4, 5, 5, maybe you hold the 5s. Here's a small straight right here, and I'm going to go for a large straight. Well, I need a 1 or a 6. So it's going to be the exact same probabilities as that full house. So what would happen though if I rolled this? Well, here again is a small straight, but I don't have anything I can roll on this side. I can only roll a 5. Well, that's a 1/6 chance of getting it, and there is a 5/6 chance of not getting it, and another 1/6 chance that you get it over here. So this is 1/6 plus 5, 36, which is 6, 36 plus 5, 36. There is less than a 1/3 chance. Unless, yeah, because 1/3 would be 12 out of 36. There is less than a 1 out of 3 chance that you would get the small straight here. I'm sorry, the large straight. So as you can see, this isn't binomial probability or anything. This is just straight. How many ways can this happen divided by the total number of possible outcomes? And then you have to think there's the probability that you're going to roll a second time if you get this is 1 if you're going for the straight. And if you don't get it here, there's a 2/3 chance that you're going to have to go to the 3rd roll. And when you get to that 3rd roll, there's still a 1/3 chance that you're going to get a 1 or a 6. So you had a fourth roll, it would be 2/3 times 2/3 or 4/9, et cetera, et cetera. But we don't get a fourth roll. So anyway, that's how you play Yahtzee. That's how just a couple of examples of how you can use probabilities when you play Yahtzee. And it's fun to play it, look at the probabilities and say, what's the best bet here? What should I hold? What's going to generate the most points? What's the most likely thing to happen? So that's all I've got for you now. Have a great day.